Alright guys, this video for Trig is from 6.1 and for pre-cal's from 5.1. It's called Verifying Trig Identities. So what you're doing in this lesson is they're going to give you either an expression and your job is to simplify it and make it as small and as easy as possible. Or they're going to give you an equation and you need to prove that both sides are indeed equivalent. They will all be equal to each other, both sides. They'll have trig functions within them. Your job is just to prove it, okay? So don't ever think they're going to give you one that's not true. If you try and make one up on your own, it'll most likely not be true, but these will all eventually be equal to each other, okay? So the 3 steps in making them equal to each other. Step 1 is to simplify using Pythagorean, okay? So over here with little parentheses 1, I give you a refresher on Pythagorean. Now the 3 stars are the 3 that you had memorized from the previous course, okay? So you should have had memorized that previous chapter. You should have memorized that sine squared plus cosine squared equals 1. Now, it's very useful to understand how you can rewrite this in different ways. For example, do you agree that if I subtract the cosine squared over to the other side, I have sine squared equals 1 minus cosine squared? Does that make sense? And the same works if I want to leave cosine squared by itself and subtract sine squared over, then I have this third one, cosine squared equals 1 minus sine squared. Okay? The second one you memorize is 1 plus tangent squared equals secant squared. And again, I can subtract the tangent squared over and leave the 1 by itself. Or I can subtract the 1 over and have tangent squared by itself like this third one. And we can do the exact same thing to the third one we had memorized. 1 plus cotangent squared equals cosecant squared. I can subtract the cotangent squared over and leave the 1 by itself. Or I can subtract the 1 over and leave cotangent squared by itself. Okay? All right, step 2 is to change everything to sine and cosine. Step 2 for me is one of the most powerful steps because if we have 6 trig functions and we can change everything to sine and cosine, now I'm only working with 2 trig functions. It makes my life a lot easier. So for step 2, I put you a little remember for step 2. If I have a cosecant, secant, tangent, or cotangent, which are the 4 non-sine and cosines, these are the rules that we had learned last chapter on how to change them back, okay? So these 2 on the left are the reciprocals, and these 2 on the right are the quotient rules, okay? Remember notes for step number 3, clean with arithmetic, okay? So the first thing I want to remember is adding fractions. So I put you a very simple reminder with numbers, okay? When we're adding fractions, if we don't have the same denominator, we need to get the same denominator. And the way we do that is like whatever number was down here, we usually multiplied it top and bottom to the other side. And same for this side, right? So then we can combine it. So let's finish this problem off together. What would I have to do to get a common denominator here? Multiply. Do you see that the right side needs a sine of x on the denominator? Move it up a little bit. So if I multiply the right side by sine of x over sine of x, I now have 1 over sine of x minus, what is sine times sine? Sine squared of x. Over 1 times sine is just sine of x. Okay? So now that I have a common denominator, I can write that denominator 1 time. And in the numerator, now I can combine 1 minus sine squared. Are we comfortable on the subtraction? Now what you're going to continue to learn more on in this chapter is, what does 1 minus sine squared equal? We wrote it up here. Cosine squared. So I can continue making this even simpler by saying cosine squared of x over sine. Okay, and I'm going to stop there. That can technically continue to be clean, but for now I just want you to refresh on the subtracting. So the goal for learning this is when you take your next step into calculus, if you see a big problem like 1 over sine minus sine, it's going to be much easier to do the calculus to this one single term versus both of these. Okay? Actually, let's Let's see what happens. You agree that cosine squared means that there was two cosines, right? Okay, so I could also write this problem as cosine of x times cosine of x over sine of x. If I combine these two, what does cosine over sine give me? Cotangent. So I could also call this cosine of x times cotangent. Okay? So two different options. So the whole point of this section for today's video is going to be to try and like rewrite things in different ways so you can match them. So now for dividing fractions, again, a very simple problem here. We remember that we keep change flip, we multiply by the reciprocal. So if I'm dividing 1 over sine by sine, remember this is like saying sine over 1. So then I'd say 1 over sine times 1 over sine. And that would give me 1 over sine squared of x. Okay? This is one option. If I did not want that written as a fraction, what do you think I could call 1 over sine squared of x? Cosecant squared of x, right? Oh, that's ready. Okay, so no matter what the exponent is, let's look at these rules really quick. If I had sine to the 16th over cosine to the 16th, I can call that tangent to the 16th, okay? So these rules apply no matter what the exponents are. All right, guys, last thing I want to tell you is that these 3 steps is a suggested order. Steps 2 and 3 specifically are interchangeable. So whatever you feel comfortable doing first between step 2 or 3 should still get you the exact answer, okay? All right, so here's our first question. It says to simplify cosine times, and in parentheses says secant minus cosine, okay? So step 1 says to check for Pythagorean. What your eyes should do when you're checking for Pythagorean is to look for exponents that are 2. Do you see any exponents of 2 here? No, right? Whenever you don't see exponents of 2, you skip step 1. Don't be afraid if the majority of the time you are skipping step 1, okay? So now, I told you that steps 2 and 3 are interchangeable. I'm going to show you both options. First, I'm going to show you how it works when you take step 2 first. If I change everything to cosine and sine, cosine is already a cosine. I can leave it as is, okay? How would I change secant to a cosine or sine? 1 over cosine of x minus, and cosine is already a cosine, okay? Now, I'm going to take a moment to put my parentheses because PEMDAS says I have one of 2 options here. I can get common denominator on the inside and combine that and then multiply by a cosine, or I can distribute the cosine. Either way, I am taking step 3 next. I'm going to do arithmetic, okay? So let's distribute. If I distribute, I have cosine of x over cosine of x minus cosine squared of x. What does cosine over cosine give me? 1 minus cosine squared of x. If you feel like you've exhausted your 3 steps, start over. Start from the top. The moment you spot a 2 in the exponent, you can recheck step 1. So do you see how I see a 2 in the exponent? Okay, was there a rule that we wrote down for 1 minus cosine squared? Yeah. What was it? Sine squared. And that's as simple as it's going to get. That's it. All we did was make this problem that looked a lot lengthier and messier, and we simplified it. So now I'm going to show you if we take step 3 first. Okay. Step 3 says to apply the arithmetic. So what I'm going to do is I'm going to distribute first. Cosine times secant is, I can't combine that yet, it's just cosine times secant. Minus cosine times cosine is cosine squared. So I took step 3 first. Now let's go back and take step 2. Let's change anything that is not already cosine and sine to cosine and sine. So this is good here, and this cosine squared is good. Let me change the secant. And PEMDAS says that I have to clean any multiplication and division first before I can subtract. So here I have cosine of x over cosine of x minus cosine squared of x. Cosine over cosine is 1. And notice that I'm at the exact same step that I ended up in on the other side. Okay? So this next question, we have secant minus sine times tangent equals cosine. Your goal is to get the more complicated side and start trying to make it simpler to look like the other side. So here, step 1, Pythagorean, I don't see any squares, so I get to skip step 1. Step 2 is changing everything to sine and cosine. So secant, I would write 1 over cosine. Minus, sine is already a sine, so I'm going to leave it. And if I'm starting to see fractions, I'm going to write sine of x over 1. Just to keep seeing everything in a straight line, okay? Now I want tangent to be read in terms of sine and cosine. Tangent is equal to sine over cosine. Beautiful. Now I'm going to take step 3 and start applying some addition, subtraction, multiplication, and division. PEMDAS says I have to do multiplication first. So this is going to read minus sine squared over cosine of x. Okay. Do I have a common denominator? Yep, I'm good. Okay. Remember, all of this should be reading cosine at the end. So if I have a common denominator, I could say 1 minus sine squared of x over cosine of x. What can I clean here next? I see a squared. Very good. I can use a Pythagorean. What does 1 minus sine squared give me? Cosine squared of x over cosine of x. Now, at this point, I'm going to give you 2 options. Okay? Because option number 1 is that I can reduce the left side. What do I get if I reduce the left side? I have 2 cosines on the numerator and 1 on the denominator. I just get one of them in the numerator, right? And then I'd have cosine equals cosine. Option number 2, awesome, is that I can multiply this cosine in the denominator over to the other side, and then my final answer would read cosine squared equals cosine squared. The moment that I have the pendulum equal on both sides, even if you have something different than each other and then my answer key, you are correct. Does that make sense? So let's say option 1 would be to say that I have 2 cosines in the numerator and 1 in the denominator. So these 2 can cancel, and I have cosine equals cosine. Okay. Option 2 would be to say cosine squared over cosine of x equals cosine. And then we multiply this cosine over. And I have cosine squared of x equals cosine squared of x. So your final answers could be this or this. And you are still 100% correct. Okay? All right, for this question, there are many options. Okay? Because I see squares in all terms, I want to go ahead and look at my list of 9 Pythagorean rules. Remember, there are really 3. The other ones are just rewriting. Hopefully, the first one that catches your attention is cosine squared and sine squared equals 1. Okay? And then I can bring everything else down. And now here, I have options because cotangent squared plus 1 is a rule. Okay? If you look back at your rules, you should catch that cotangent squared plus 1 equals cosecant squared, and then I'm done. But maybe your eyes caught that cosecant squared and cotangent squared is a rule, and you might want to subtract that over, and then you can get 1 on both sides. Either way, you would still be right as long as the left and the right are equivalent at the end of your problem. Okay? And that would be your final answer. Again, as long as you have the left and the right side equivalent to each other. For this next question, we have on the left side tangent squared minus sine squared. And then on the right side equals tangent squared times sine squared. So hopefully your eyes catch that there are squares. Okay, so Pythagorean should be your first check. But remember that Pythagorean is separated by addition or subtraction, which means I cannot use it on the right side. If I do try and use it on the left side, who does sine squared go with on the Pythagoreans? Cosine squared. And who does tangent squared go with on the Pythagoreans? Secant squared. So these two don't go together in the Pythagorean. So although you may think you might take a peek, like maybe I can use the Pythagorean, you see that none of them work. Okay? So my next step is to change everything to sine and cosine. Tangent is sine over cosine, but because tangent is squared, the sine and the cosine have to be as well. So sine squared over cosine squared minus, if I'm writing fractions, I need to write this one as a fraction as well. I'd write it over 1. And then over here, again, I'm writing sine squared over cosine squared times sine squared of x over 1. So for my next step on the left, I want to get a common denominator. So this fraction here with the 1 needs a cosine squared. Okay. So if I have sine squared of x over cosine squared of x minus, don't be afraid if this looks messy, sine squared of x times cosine squared of x over cosine squared of x. Now, for some reason, our minds are so eager to reduce that we want to cross out these two cosine squareds. But remember, we just did that on purpose so that we could have a common denominator. So be careful, okay? Have sine squared of x minus sine squared of x times cosine squared of x. All of this is over cosine squared of x. Now, on my right side, I'm just going to multiply straight across. What does the sine squared times the sine squared give me? Sine to the 4th. Remember, when we have the same base, we add the exponents, okay? Over cosine squared times 1 is just cosine squared. I'm going to rewrite it because there's nothing I can really clean there. Now, anytime you find in these problems that your denominators are identical, you can ignore the denominators and just worry about the numerators. Making up words. The numerator, okay? And the reason we're allowed to do that is if I multiply this cosine squared to the other side, so I'm going to multiply a cosine squared to both sides. it cancels them out. Okay, so now I have a lot less to look at. Okay. So when I look at this question, be careful not to subtract these two sine squareds. Remember that this one on the right has a cosine squared stuck to it, okay? But I have three terms, 1, 2, and 3. I see that all three of those have a sine squared in common. I am allowed to divide all three of those terms by a sine squared. Okay? Now, please be careful not to just cross these two out. What is sine squared divided by sine squared? 1 minus these two also equal 1. 1 times cosine squared is just cosine squared. And then if I have the same base, what do I do with those exponents? Very good, I subtract. So 4 minus 2 is 2. So I have a sign with an exponent of 2. Or you can see it as that I have 4 in the top and 2 in the bottom. So I can cancel out 2 in the top with 2 in the bottom. And I'm left with a sine squared. What do you guys think my last step is? Whoops. Right. 1 minus cos... Oh, my pen stopped working. 1 minus cosine squared is sine squared. This would be considered a more difficult problem, guys, okay? Don't think this was an easy one that you just had a brain fart. This is a trickier one, okay?